Present value of a perpetuity. In previous modules, we've looked at how we can calculate the present value or future value of any cash flow. In the previous module, we looked at calculating the present value and future value of a series of cash flows. What we found then is that we have to multiply or divide each cash flow by the interest rate factor, 1 plus r, to the power of the number of periods that we need to move that cash flow forward or backward in time. But what if there are lots of cash flows? This would become very tedious if we wanted to work out the present value or the future value of this many cash flows. We'll look at how we can do that using a shortcut in the next module. For this module, we're looking at perpetuities, which are cash flows that continue indefinitely or in perpetuity. Not only would it be tedious to try and work out the present value of a large number of cash flows, it's literally impossible to calculate the present value of an infinite stream of cash flows using the techniques that we've looked at so far. However, there is a shortcut that will allow us to work out the present value of an infinite stream of cash flows. Just to make the diagrams a bit easier to follow, we'll just show the first few cash flows of the perpetuity. Now, it doesn't make any sense to talk about the future value of a perpetuity. This would be an infinitely large number, infinitely far into the future. However, it is possible to calculate the present value of an infinite stream of cash flows. The reason for that is that as those cash flows move further and further into the future, they are discounted more and more, and the present value of a far distant cash flow approaches zero. Before we look at the formula that we need to calculate the present value of a perpetuity, it's important to note that each cash flow occurs at the end of each period. So the first cash flow occurs at the end of period 1, and so on. This is important because the formulas that we will use in this and the next module are all based on the assumption that each cash flow occurs at the end of a period. If that's not going to be the case, then we need to make an adjustment, and we'll talk about that sort of adjustment in the next module. The formula for the present value of a perpetuity is this, probably the simplest formula that we will use in this entire subject. The present value of a perpetuity is just the constant cash flow divided by the interest rate. Let's do an example of that. What is the present value of $200 to be paid every year in perpetuity, with the first payment 1 year from now, if the interest rate is 6% per annum compounded annually? See if you can work out the answer to this question. The present value of this perpetuity is the constant cash flow of $200 divided by the interest rate, 0.06. The other thing we need to talk about in this module is something called a growing perpetuity. Notice in this diagram that each cash flow has a different subscript to denote which year it occurs, C1, C2, C3, etc. If those cash flows are completely different, then there is no practical way of calculating the present value. The only way that we can calculate the present value of a perpetuity where the cash flows are different from each other is if they are growing at a constant rate. So that means that C2 is equal to C1 times 1 plus G, where G is the growth rate. C3 is equal to C2 times 1 plus G, where C2 is growing at the same growth rate, and so on. Another way to calculate C3 would be to take C1 and multiply by 1 plus G squared, and so on. The formula for the present value of a growing perpetuity is this. The first cash flow, C1, divided by R minus G. Once again, we note that the first cash flow occurs at the end of the first period. So C1 occurs one period in the future. R is the interest rate per period, G is the growth rate, and it's important to note that R must be greater than G. If R is equal to G, then we're dividing something by 0, and that's not possible. And if the growth rate is greater than the discount rate, if the cash flows are growing at a greater rate than the rate at which we are discounting them to a present value, then the present value would be infinite. Sometimes we don't actually know what C1 is. In some situations, we are given other information and we need to work out what C1 is. The most common example is a share where the dividend is growing at a constant rate, and we know the most recent dividend, which we can call C0. C0 is not part of the future cash flows and doesn't actually get included in the present value, but we can use C0 to calculate C1. As you can see, there are effectively two versions of this formula. The first one is the one that we've already looked at. The present value of a growing perpetuity is C1 over R minus G. If we are given C0, we need to use that information to calculate C1. So the numerator of this formula becomes C0 times 1 plus G. So let's do an example of a growing perpetuity. What is the present value of a growing perpetuity with annual payments, an initial payment of $200 in 1 year, and growing at 2% every year if the interest rate is 6% per annum? We take C1 and put that in as the numerator in our formula. R is 6% or 0.06, G is 2%, 0.02, and the answer is $5,000.